Hello guys, today I'm going to be showing off my EEPROM programmer that I built with a Raspberry Pi 3B actually. And I'm using 2 shift registers, an EEPROM, some LEDs, and a lot of jumper wire. So here's a very bad, very quickly drawn diagram of it. Here you can see this is the Raspberry Pi. It looks very bad, I know. 2 shift registers, and then my EEPROM. I'm using a AT28C256. The 2 shift registers connect to the EEPROM's address pins, and then the I/O pins connect directly to the Raspberry Pi, and then the write enable, output enable, and the chip enable too connect directly to the Raspberry Pi. The reason why my address pins don't connect directly to the Raspberry Pi is because the Raspberry Pi doesn't really have that many GPIO pins. With a shift register, with just 5 pins, we can control basically an infinite amount of outputs. In this case 16, though we actually only need 15 because there's only 15 address pins. So let me show this off again. I have my Raspberry Pi and 2 shift registers that are here. Sorry for the wire mess. Maybe I'll make this a bit better someday. From here you can see the address, the LEDs that show which address are we on. And then these red LEDs show us what data is actually in the EEPROM. These 3 LEDs, this is output enable, this is write enable, and this is chip enable. So right now we're reading address 0. Let's read address 1. Now we can see that the data that we're storing is 6F, about address 2. It has 6E. So it isn't F this time because these 3 are pulled high, but this is. So here's my screen, and here, for example, this will put us back to reading address 0. So next I'll show you how can we write to the EEPROM. So I found a nice little place where we can put some data. I don't want to overwrite stuff that I have written in the EEPROM. So address 0x2100 is kind of like empty, or it has written to it the new line character. Let's go back to address 0x2100, and if I put in the command line ERA write, I don't know, 0xFF, like so, it will write all ones. So another thing I programmed into the ERAR program is actually writing files, like writing the contents of files to the EEPROM. This could be useful when potentially making, a breadboard computer, or any, computer that's using an EEPROM for the programs that you're gonna run or something like that, a bit like Ben Eater does. Obviously this is inspired by Ben Eater's EEPROM programmer build. So I have this little file here. That's just a text file, so it's called opening.txt. So let's run this program, and what it's gonna do is it's gonna write everything on opening.txt to the EEPROM. Okay, I'm ready to write the contents of opening.txt to address 0x2100 and beyond. Let's see what it looks like. And here it is. As you can see, it's writing data to the EEPROM, and it wrote it, and it ended in 0x08. The reason is that's a new line, so I'm pretty sure that ends in a new line, or now I'm actually sure about it. There's still one more function that I have not shown you, and that is read all. Let's read the contents of 0x. Let's read the contents of the EEPROM from 0x 2100 to 0x22FA, which is where, as you can see, that's where the contents of this end. And that's the address that is being displayed right now. So we just get hex from this, but it kind of looks logical, in my opinion at least. But if we put the C option, it will actually print it as characters. And, there, as you can see, text of opening.txt being displayed here. Yeah, this is my EEPROM programmer with a Raspberry Pi using 2 shift registers, 1 EEPROM, and nothing else. It just looks very satisfying because I have the LEDs, so I just love seeing the EEPROM being read. And if I actually read everything, here's what gets outputted. It's kind of a longer process. As you can see, it's going from address to address there, and here it's outputting all the data. Yeah, thank you for watching. Really appreciate it. Bye.